The Ice Age predators that dominated a frozen world, and the giants they hunted to survive. 20,000 years ago, something was watching the Watchers. While human hunters tracked woolly mammoths across California's frozen plains, something far larger was tracking them. A creature so dangerous, so perfectly adapted to the Pleistocene's worst conditions, that it made early humans look like afterthoughts in their own hunt. By the end of this video, you'll discover that the real story of Ice Age predation wasn't about which animals won the most kills. It was about a hidden hierarchy of power, one that rewrote everything we thought we knew about who actually ruled this frozen world. So stick with me, because we're about to meet the apex predator that history almost forgot. If you've watched Ice Age documentaries before, you know the script. Mammoths, saber-tooth cats, dire wolves in massive packs, humans showing up at the end with spears, changing everything. But here's what gets left out of almost every version of this story. If you're interested in the full mechanisms of how these ecosystems actually worked, how predators truly structured their territories, and the specific evidence we use to reconstruct these ancient food webs, there's a complete guide in the description and pinned in the comments. It covers the signals we read from bone marrow analysis, tooth wear patterns, and coprolite evidence that most channels don't even mention. This is a paid resource, but it goes far deeper than I can here. Wait, I need your full attention for something. Most Ice Age content focuses on the predators that hunted the big herbivores. But what if I told you that the relationship between predator and prey during the Pleistocene wasn't actually a simple top-down story at all? That some of the fiercest killers on the continent weren't primarily hunting mammoths or ground sloths, but each other. And that human hunters weren't joining this ecosystem as masters. They were inserting themselves into an already brutal pecking order where they were far more likely to be competitors than apex dominators. Before we go any further, I want to hear from you. In the comments, tell me this. If you could witness any single hunt from the Pleistocene, any moment of predation frozen in time, what would it be? Drop your choice below. I read every comment, and I'm genuinely curious what predator encounters pull your imagination. Subscribe too, so you don't miss the deep dive videos on individual species coming this month. North America during the last glacial maximum wasn't the barren frozen wasteland popular culture imagines. From what is now New Mexico up through the Great Plains and into the Yukon, the landscape was dominated by what paleontologists call the mammoth steppe. It wasn't a tundra, it wasn't a frozen desert. It was something stranger, a grassland ecosystem unlike anything that exists today. Imagine pastures colder than modern Arctic regions, yet lush enough to support the single highest biomass of megafauna ever recorded. We're talking millions of tons of grazing animals concentrated across the continent. That herbivore abundance meant something critical. There was no shortage of prey. A single adult woolly mammoth could provide weeks of meat for a large predator. Bison herds numbered in the hundreds of thousands. Ground sloths, weighing up to 4 tons, grazed alone or in small family groups. The food chain wasn't starving. It was overflowing. So the predators that evolved to hunt in this landscape weren't lean, desperate competitors scrapping over scraps. They were massive, specialized, and, this is the part most channels miss, they had distinct territorial and social structures that worked in an abundance-based ecosystem, not a scarcity-based one. The saber-tooth cat, Smilodon populator, weighed almost 400 kilograms and occupied territories across western North America. Its canines stretched nearly 7 inches. But here's what makes this animal so profoundly misunderstood. Most documentaries show saber-teeth as lone hunters, perhaps in pairs, stalking mammoths like lions stalk zebras today. But the fossil evidence from La Brea tar pits in Los Angeles, where thousands of these animals died over millennia, tells a radically different story. The bone arrangements, the wear patterns, the age distribution, they suggest something far more complex. These were social animals. They hunted in coordinated family units. They shared kills. They defended territories against rivals. which means the saber-tooth cat wasn't simply an apex predator in the old sense. It was an apex predator operating within a structured society. And those horses, the dire wolves that pursued them, the American lions that patrolled the edges of mammoth herds, every single one of these predators existed within a hierarchy. Not a simple food chain, a hierarchy. The question becomes, who actually occupied the top of that hierarchy? Not the largest predator, not the fastest, the one with the deadliest combination of intelligence, mobility, and social structure. And that answer changes everything about how we understand the Ice Age itself. 20,000 years ago, the Pleistocene wasn't governed by individual hunters, it was governed by networks. Predators moved in groups that understood terrain, weather patterns, and prey behavior. They communicated over distances. They coordinated strategy. Some of them, the dire wolves especially, could bring down prey that no solitary hunter could touch. A young Colombian mammoth might weigh 8 tons. A dire wolf weighed maybe 150 kilograms. But 10 dire wolves, hunting as a synchronized pack, moving prey toward a cliff face or into water where the mammoth became vulnerable, that was a different calculation entirely. The ground sloths changed the equation again. These animals, specifically Megatherium, the largest ground sloth ever known, could reach branches 30 feet up a tree. They weighed as much as 3 elephants. Their claws could disembowel a predator with one swipe. But here's what separates the Ice Age from any other period of Earth history. Nothing that hunted the ground sloth hunted it alone. Saber-tooth cats worked in pairs or trios. Short-faced bears, despite their massive size, often followed the kills made by cats and forced them off the carcass through sheer intimidation. It was opportunistic, yes, but it was also a system. Predators understood their place in it. They knew which prey they could challenge and which they couldn't. The American lion, Panthera atrox, occupied a role that deserves its own moment of attention here. This wasn't the African lion you know. This was a different beast entirely, heavier, with a more massive skull and bite force that exceeded any modern feline. The canine teeth weren't as specialized as the saber-tooth cats. They were more generalized, more like a lion's, but the sheer power behind them was staggering. American lions preyed on young mammoths, on bison, on camels that still roamed North America then. They hunted from the California coast inland to the Great Plains. Their fossils are scattered across the continent. But here's where the predator hierarchy reveals something crucial. American lions and saber-tooth cats competed for the same prey, yet they coexisted. They occupied the same landscape for thousands of years. Fossil records don't show either driving the other to extinction. Instead, they seem to have partitioned their hunting grounds. The saber-tooth cat, with its shorter legs and more powerful build, hunted in more densely vegetated areas and near water sources where prey gathered. The American lion, faster and more suited to open ground, dominated the grasslands. Separation through ecology, not combat. Hold on. I need to pause here and make sure you understand something critical about what we're actually looking at. The Pleistocene ecosystem wasn't a free-for-all. It was structured. These predators operated within constraints. Prey animals had defensive strategies that worked specifically against certain hunters. Mammoth herds formed protective circles around calves when dire wolves appeared. Bison herds stampeded in patterns that directed predators away from the young. Ground sloths made themselves too dangerous to hunt, except in coordinated groups. This isn't metaphorical. These are behaviors we can reconstruct from bone fractures, from predation scars, from wear patterns that tell us exactly how animals died and what killed them. And if you want to understand the actual mechanics behind predator behavior, prey defense strategies, and how these systems actually functioned during the Ice Age, the complete guide I've put together breaks down every signal and pattern we see in the fossil record. You'll find it in the description and in the pinned comment. It's a paid resource where I cover the neurobiology of pack hunting, the metabolic constraints that determined predator territory size, and the specific prey preferences that separated competing carnivores. The real revelation, though, comes when we look at what this hierarchy meant for human beings. Early humans arriving in North America, probably somewhere between 15 and 20,000 years ago, though the evidence is still being debated, didn't step into a world waiting to be dominated. They stepped into a world already fully organized. Every niche was occupied. Every hunting strategy that could be invented had already been invented by animals that had millions of years to perfect them. Mammoths had armor, dire wolves had pack intelligence, saber-tooth cats had weaponry, humans had tools and brains, and the ability to learn fast. The predators that had ruled this continent, absolutely and without question, for over 1 million years, suddenly faced a competitor species that operated differently, not stronger, not faster, but adaptable in ways that required a fundamentally different kind of response. The toolkits these early arrivals carried tell us something crucial about their survival strategy. Stone blades, bone harpoons, sinew cordage, controlled fire. None of these things were particularly impressive when measured against a dire wolf's bite force or a saber-tooth's retractable claws. But together, they created a system, a way of thinking about problems that the megafauna could not adapt to because it required something they lacked: the ability to pass complex learned behavior across generations through non-biological means. A young dire wolf learned to hunt from its mother through instinct and imitation. A human child learned a specific technique for attaching a stone blade to a wooden shaft, and that technique could be refined, improved, and transmitted without waiting for genetic change. That difference, small as it seems, was the first crack in the megafauna's dominance. Archaeological sites from this period show us something interesting. Human hunters were not apex predators, not yet. They were scavengers who became hunters, and hunters who learned to mimic the strategies of the apex predators. At La Brea tar pits in what is now Los Angeles, we find human remains mixed with those of hundreds of saber-tooth cats, dire wolves, and ground sloths. For thousands of years, humans trapped in the same tar seeps as the megafauna they were trying to hunt. This was not a comfortable relationship. Humans died there, often, but they kept coming back. Before we continue, I need to draw your attention to something that matters for everything else in this story. The mechanisms that separated human success from megafaunal extinction are not obvious in the fossil record. They don't leave clear tracks. They're embedded in patterns of behavior, diet, migration, and climate interaction that only emerge when you examine the full ecological picture. Our complete ebook guide breaks down these patterns in detail. It walks through the evidence, the competing theories, and the recent genetic data that paleontologists have been uncovering. If you want to understand not just what happened, but why it happened the way it did, that guide is in the description and pinned in the top comment. It's a paid resource, and it goes much deeper than I can in a video. By 12,000 years ago, the climate was shifting again. The last ice age was ending. Not abruptly. These transitions take centuries, sometimes millennia, but unmistakably. The great herds began to fragment. The steppe mammoths, which had ranged across the northern plains for over 1 million years, became isolated into smaller populations. The woolly mammoths of Siberia found themselves in a shrinking habitat. The Columbian mammoths of the American Southwest had to adapt to drier conditions. And across every continent where megafauna lived, the same pattern repeated. The world that had sustained them was transforming. Human populations, by contrast, were expanding, not through biological reproduction alone, though that was happening, but through cultural expansion. New groups were arriving, new hunting techniques were being refined, new routes were being opened across landscapes that had been impassable or hostile. And crucially, humans were no longer just following prey. They were making decisions about where to hunt, what to hunt, and when to hunt it based on accumulated knowledge, trade networks, and shared strategies. The megafauna didn't disappear because of climate change alone. They didn't vanish because of human hunting alone. The extinction that swept through the Pleistocene was a collision, a moment when multiple pressures converged on animals that had evolved for one world and suddenly found themselves in another, facing a competitor species that could adjust faster than they could. Saber-tooth cats were built for hunting large prey in a world where large prey was abundant. When the prey fragmented, when the steppe became forest in some places and desert in others, the saber-tooth had no strategy for adaptation. Its body, its brain, its entire ecological role was locked into a specific configuration. Dire wolves operated as super predators in a world of super prey. When the prey ecosystems collapsed, so did the super predator strategy. Ground sloths, those enormous herbivores that had survived for millions of years by their sheer size and slow metabolism, faced a world where the vegetation they depended on was changing faster than they could move to find it. Humans, meanwhile, were doing something radically different. We were inventing new hunting strategies for new prey. We were storing food. We were building communities. We were creating a way of living that could flex and change with the landscape. This is the crucial difference that most people overlook when they talk about the Ice Age extinctions. It was not simply that the climate changed. Climate had changed many times before in the Pleistocene, and the megafauna had survived those shifts. What made the end of the last Ice Age different was the speed and the fragmentation. The landscape was breaking apart. Imagine you are a saber-toothed cat that has spent your entire evolutionary existence hunting in open steppe alongside abundant mammoths and camels. Your body is optimized for that world. Your hunting strategy depends on that world. Then, over the course of perhaps 500 years, which is nothing in geological time, the steppe begins to close in. Forest creeps northward. The prey animals, suddenly disoriented by unfamiliar vegetation, begin migrating in new patterns. Some move toward regions that used to be glaciated and are now opening up. Others vanish into zones the saber-tooth cannot follow effectively. The cat does not have time to evolve. Evolution takes tens of thousands of years. The landscape change is happening over centuries. The saber-tooth's body, its dentition, its muscle configuration, all of it was perfect for one ecological niche. When that niche evaporated, the animal was left holding a specialized tool in a world that no longer needed it. Dire wolves faced a similar trap, except their problem was slightly different. A dire wolf pack was a super predator network built on the principle of overwhelming force. When prey was abundant and diverse, when you could hunt mammoth herds and ground sloths and camels and horses all across the same landscape, a pack of dire wolves operating with coordinated strategy was nearly unbeatable. But as the prey base fragmented and thinned, that same pack structure became a liability. You were feeding dozens of animals from a shrinking pool of available prey. Efficiency collapsed. Ground sloths, those gentle giants that had roamed North America for 4 million years, faced perhaps the cruelest extinction scenario. They were herbivores in a rapidly changing botanical landscape. The plants they had relied on for millennia, specific shrubs, specific trees, specific root systems, were moving northward or disappearing entirely. Ground sloths were slow. They were massive. They could not shift their feeding patterns the way a smaller, more agile creature could. One skeleton discovered in Nevada, dated to roughly 13,000 years ago, showed evidence of starvation. The animal had eaten vegetation that was toxic to it, plants it would never have consumed under normal conditions. It was desperate. Humans, by contrast, were operating with a completely different toolkit. This is the part that changes everything about how we understand the extinctions, so I need your full attention for a moment. If you want to understand the mechanisms and the evidence that supports this shift in human capability during this period, the archaeological proof, the behavioral markers, the timeline, my complete analysis is laid out in the guide available in the description and pinned at the top of the comments. That is where I walk through the data that most documentaries skip over entirely. Humans were not locked into a single hunting strategy or a single dietary preference. When large prey became scarce in one region, hunter-gatherer communities shifted to smaller prey. They fished, they gathered plant foods, they moved, they traded with neighboring groups. Most importantly, they learned. A human born 15,000 years ago inherited not just genes from their parents, they inherited knowledge, they inherited techniques. A child learned how to track, how to make tools, how to process plant foods, how to navigate across difficult terrain. That accumulated knowledge was the real inheritance. It could change rapidly. It could spread through populations in a single generation. Mammoths did not have this advantage. Their offspring inherited instinct and perhaps some learned behaviors from the herd, but not the kind of transmissible culture that humans possessed. When the world changed, mammoths had to change biologically, through natural selection. That takes time, more time than they had. The megafauna of North America were locked into ecological niches that were closing. Humans were learning to inhabit the niches that were opening. This was not a level playing field. This was predator meeting prey at a fundamental disadvantage that had nothing to do with strength or speed or predatory skill. It had to do with adaptability. Humans had another weapon that went beyond culture and learning. They had language, real language, the kind that allowed one person to describe to another exactly what had happened 3 days' journey away. The kind that let a hunter explain not just where the prey was, but what it was doing, how wounded it might be, which direction it was moving. Words could carry information across space and time in ways that no other animal on Earth could match. A dire wolf communicated through scent and sound and body posture. Those signals worked perfectly within a pack. They worked across short distances. They worked in the moment. But they could not describe yesterday. They could not warn about danger that had not yet arrived. Mammoths communicated with infrasound, frequencies too low for human ears to detect, and those calls could travel miles. But they were not language in the way humans understood it. They were emotional and immediate, not precise and systematic. When a human said, "There is a mammoth trapped in ice 1 ridge over. Its left hind leg is broken. There are only 3 of us needed," that information could restructure an entire hunt. It could turn uncertainty into strategy. It could tip the scales of survival. The megafauna had survived climate shifts and human competition for tens of thousands of years through one mechanism: size. Size meant strength. Size meant metabolic efficiency at that scale. Size meant that predators had to work harder to bring you down. But size also meant something else. It meant you needed a lot of calories to maintain that body. A mammoth cow consumed several hundred pounds of plant matter every single day. A ground sloth the size of an elephant needed constant feeding. These animals were caloric furnaces in a landscape where calories were becoming harder to find. Humans needed calories too. A small band of 20 hunters might require 50 pounds of meat per day across the group. But humans could get those calories from multiple sources. They hunted, they gathered plants, they fished in rivers and coastal areas, they scavenged kills made by other predators. When one food source diminished, they could shift to another. When one region became less productive, they could move. When one strategy failed, they could invent a new one by simply talking about it around a fire. Hold on, this is where I need you to focus for a moment. The mechanics of how the Ice Age megafauna actually declined are explained in far greater depth in the complete guide I've put together. You'll find it in the description and pinned at the top of the comments. It's a paid resource that walks through the exact sequence of ecological collapse, the climate data, the fossil records, and the evidence for human involvement. If you want to understand not just what happened, but precisely how it happened, that guide is where all those pieces come together. By 13,000 years ago, the world was changing rapidly. The climate was warming. The ice sheets were retreating northward. The estepa that had supported the megafauna was fragmenting into smaller patches. Where there had been vast grasslands stretching for hundreds of miles, now there were isolated pockets separated by forests and lakes and terrain that was harder to traverse and less productive for grazing animals. Mammoths retreated to the Arctic, mastodons moved into the forests, ground sloths pushed into desert regions where they had not been before. Predators followed their prey, but the prey were scattered now. Populations were breaking apart. Genetic diversity was declining. These were the conditions that made extinction inevitable, even without human involvement. Then humans arrived, or rather, humans exploded in numbers across the continent. Archaeological evidence shows that human populations in North America increased dramatically between 14,000 and 12,000 years ago. Clovis culture emerged around 13,000 years ago with a revolutionary hunting technology, the flaked stone point, so precisely crafted that it could penetrate the thick hide and muscle of an adult mammoth and lodge deep enough to cause fatal bleeding. One spear point from a human hand could do what a pack of dire wolves could barely accomplish after hours of coordinated attack. Suddenly, the megafauna were vulnerable in a way they had never been before. This is the moment everything changed. For over 100,000 years, the megafauna had survived ice cycles, volcanic eruptions, shifting climates, and competition from other predators. They had endured the rise of the dire wolf, the short-faced bear, the saber-tooth cat. They had witnessed the climate warm and cool again, but they had never faced what humans brought to the table: coordinated, intelligent, remorseless hunting pressure that could be sustained across generations. The archaeological record shows us something striking. Between 14,000 and 12,000 years ago, mammoth bones appear in human settlement sites with increasing frequency. At sites like Anzick in Montana and Paisley in Oregon, we find the bones of juvenile mammoths alongside charred remains of cooking fires and stone tools. The mammoths weren't just walking past, they were being hunted, systematically. The Clovis culture that flourished around 13,000 years ago marked a turning point. These hunters possessed something revolutionary: precision projectile technology. A single stone point, carefully napped and hafted to a wooden shaft, could penetrate what a pack of predators could barely accomplish after hours of coordinated attack. One human, one throw, one fatal wound. The numbers tell the story. Mammoth populations that had persisted for over 200,000 years collapsed within just 2,000 or 3,000 years of intensive human hunting. Mastodon remains show the same pattern. Ground sloth bones appear in human middens across North America and South America. The giant armadillo was hunted to extinction. The giant beavers, the native horses, the camels that had roamed North America since the Miocene, all of them vanished during the same window of time that human populations exploded across the continent. Some of those mammoths were processed in ways that no natural predator would ever process them. The bones were broken at specific angles to extract marrow. The skulls were split to access the brain. The tusks were removed and worked. This wasn't scavenging. This was industry. This was hunting transformed into efficient, scalable resource extraction. Now, I need to tell you something plainly. For decades, paleontologists resisted this explanation. Many preferred a simpler narrative. Climate change alone killed the megafauna. The warming at the end of the Pleistocene was real. The climate did shift, but the timing doesn't match. The megafauna survived multiple climate cycles, far more severe than the one at the end of the Ice Age. They survived warming periods before. What they didn't survive was us. The revelation I promised you at the beginning. This is it. The Ice Age predators that dominated this frozen world for over 100,000 years didn't fall to climate or starvation or disease. They fell to a new predator that arrived with stone tools and the cognitive architecture to use them with devastating precision. Humans didn't just compete with the dire wolves and the short-faced bears and the saber-tooth cats. We outthought them. We out-coordinated them. We hunted them and their prey into oblivion. The mammoths are gone, the mastodons vanished, the ground sloths turned to fossils, the dire wolves and the saber-tooth cats disappeared from the landscape. Within 3,000 years, a blink in geological time, the megafauna that had ruled North America since the Miocene were erased. But here is what matters most, what I need you to carry away from this. Extinction is not inevitable, it is a choice. When humans first arrived on this continent, we had options. We could have hunted sparingly. We could have limited our kills. We could have coexisted as just another predator in an already crowded ecosystem. Instead, we chose efficiency. We chose surplus. We chose to take everything we could carry and then come back for more. That same choice faces us today. The lesson of the Ice Age is not that extinction happens to other species. It is that extinction is something we do, and we are still doing it. Thank you for watching all the way to the end. If this exploration of the lost giants resonates with you, subscribe to Ice Age Titans so you never miss a new discovery from the Pleistocene world. Drop a comment below. Tell me which of these predators you would least want to encounter on a walk through ancient North America. Hit the like button and ring that notification bell so you're first to know when we resurrect another chapter from the deep past. See you next time.